Assalamu alaikum, a very good morning dear students, and welcome back to your physics class. And this is your physics teacher from United Public School. So students, we have already discussed about the information of atom right in our last class, in our earlier classes. Now in our today's class we are going to discuss about the structure of atom, how the atoms look like, what is the arrangement of atom, what is the arrangement of particles inside or on the atoms. Okay, right? So we are going to discuss about the arrangement of particles, small particles or small things which is present on the atom or inside the atom. So many theories are put forward to explain the structure of atom. In that, here J.J. Thompson, who is one of the famous scientists. So here J.J. Thompson proposed a model, that is Thompson model of an atom. So this model was proposed by J.J. Thompson in 1898. So here J.J. Thompson complete name is, remember we have already discussed in our last class, that is Joseph John Thompson. So actually this model was commonly named as Plum pudding model, referring to the way that the fruit species are distributed throughout the plum pudding according to the model. So according to this model, what we are telling, he was referring as plum pudding model. Why? Because he was telling that the fruit pieces which is distributed inside the plum, here as you can see in this picture, he was referring this model. Why? Because this is a pudding, right? So here pudding is indicating as the atom, and these nuts, peanuts or some chocolate chips which are distributed in this pudding was referring as the electrons or the particles which is present inside the atom. So basing on this, the name was given as plum pudding model. So according to this model, what the Sir J.J. Thompson saying is, he want to say that the atoms, inside the atoms, they have positively charged charged electrons and electrons. Positively charged electrons and negatively charged electrons are present. But here, uniformly the positive charged electrons are present inside the atom, and electrons which is the negatively charged are embedded like a seed. He was also given the example of watermelon, like you can see here they have plum. This red color pulp are indicating as a positive charge, and these black seeds which is completely distributed inside the watermelon is indicated as a negative charge. Similarly, these atoms are similar to this watermelon that J.J. Thompson has said. This is the first point. So moving towards second point, the mass of atom. Mass in the sense, as you all know, weight. So the weight of the atom is uniformly distributed, completely, not a balance. One side is too much balance and another side is only some balance. Is not like that. Here the mass, the weight of the atom is distributed throughout the atom. So next third point says us that negative and positive charges are supposed to balance out. So as I said before only, the weight is completely distributed. The mass of the atom is completely distributed all over the atom. So here these positive and negative charges are also supposed to maintain the balance of the atom, and it is electrically neutral. So similar to the plum pudding model, I also told you about the watermelon, right? So here that information was given. So that is, the positive charges are spread out the atoms like a red part of the watermelon. The red juicy pulp part of the watermelon is like a positive charge, and the black seed which is completely distributed in the watermelon is represented as the electrons. Is okay? So now Thompson model was modified, in the sense changes by his own student only, but there is some reasons. So behind that reasons, Thompson also gave some explanation also. But why the student has been questioned to change the modification? Because of some experiment was carried out by Rutherford also. So that we are going to discuss over here. So before going to discuss that, let me show you a picture. So see here. See, this is the atom and this is the watermelon. As you can see, this red pulp or orange part is like a red pulp purple juice, and these minus charges are green like charges are like a black seeds. Okay. So next we have Rutherford's alpha particle scattering experiment. So here Sir Rutherford, he did an experiment taking out alpha particle. Why only alpha particle he chose to do this experiment? Because of some reasons that also we are going to discuss. So before that, here Rutherford's complete name is Ernest Rutherford. He was a scientist. He was born in New Zealand and in 1909. So he was done this experiment by using gold foil paper. What is the gold foil paper? As you know, silver foil paper, maybe you have already seen that here he was used gold color foil paper and alpha particle. So here this alpha particle consists of 2 protons and 2 neutrons, which is bounded together. Okay, so they do not have any electron. This alpha particle do not have any electron. They are positively charged and with 2 units of charges. So as you can see in this picture here, the Rutherford has put an alpha particle, and here he was passing some light rays. These alpha particle sources are coming from over here, and here this is the screen, white color screen or black color screen. Here this golden foil paper, when the light rays of alpha particles coming over here, these alpha particle light rays are scattering over here. As you can see, in one direction not going, the light rays are going in different directions. Some are over here, some over here, some are reflecting back also. Okay. So actually, but what is the reason of choosing alpha particle is this alpha particle has 2 units of charges, plus it has high energy. Large amount of energy was accumulated inside the alpha particles, as well as another reason is there, that is the mass, the weight of alpha particle is so much, so that the alpha particle has more energy, then the light rays will be in full energy of the direction. Okay. But Thompson was Rutherford expected that these light rays will be deflected in the sense bending. So when the light rays or fall on this gold foil paper, it will bend. He thought Rutherford, but all light rays are scattered. It was distributed in different directions. Some are straightly, some are deviated, some are reflected back on the another direction also. So as you can see in this figure number 4, scattering of alpha particles, or many rays, some rays are bouncing back, some rays are going in a straight line, some are bending like this, and some are bending in this direction also, some are bending in this direction and bouncing back like this. In this direction, in this diagram you can clearly observe these are the atoms, gold foil atoms. Okay, so here light rays are passing in different direction, that is the scattering of alpha particles. So a beam of bundle of alpha particles, all are these alpha particles, some are in small angle, they are bending, some are going in a straight line, as you can see over here, some are changing in direction. So some are going in a straight direction, some are bending. Why? Because when it is a single atom, it is a single atom. So when the light is passing over here, it is bouncing bouncing at a particular particle, that is over here. As you can see here, it is bouncing it to the proton. When it bouncing to the proton, it is changing in direction. But when it is going in a electron, it is going in a straight direction. So when the electron is present, it is going in a straight direction, but when it is bouncing with a proton, it is changing its direction in bending some angle or bouncing back to the same direction. So you also gave the example of stone. When we throw a stone on a wall, what happens? This stone will strike on the wall and it will bounce back in some other direction, right? But when we throw a stone over the net like structure, so some stones will bounce back and some stones will get through the net, right? So he gave this example, as well as Similarly, alpha particles also acting as the same parts like atoms. Even the protons and electrons are playing exactly main role in passing through the light rays or changing the direction of light rays. That's it. So overall, these experiment, Rutherford concluded some 2 points, that is, most of the space inside the atom is empty. Many of the place is empty. Some or most of the place is occupied by alpha particles, which is passing through the gold foil, as you have already seen in the diagram. And a very small fraction of alpha particles are deflected, in the sense changing the place or bending. Okay, so most of the light rays are bending back and indicating that they meet with a very large positive charge, right? And the mass which expel the charge on the alpha particle, expel in the sense throwing back, repelled. So repelled in the sense turning back side. So some light rays force turning back side also, that is because of positive charges. ठीक है, right? So this is all about Rutherford model of atom. Okay, so here we are going to stop our class. In our next class we will discuss about basis on this experiment. Rutherford put forward his nuclear model of the atom, basing some features that we are going to discuss in our next class. So students, your today's homework is in your textbook, page number 150, you have figure number 5, that is alpha particle scattering experiment. This diagram you need to draw in your notes along with these parts, all parts, and neatly draw this diagram. And another diagram, 2 diagrams you need to draw in your homework notes. That is figure number 4. This is the Rutherford observation, scattering of alpha particle. You need to draw both diagrams in your notes. Okay, thank you students.